Yeah, it's visible.
Yeah. Actually, you said you'd be putting it in the Zoom chat, right? Can I see the Zoom chat while I'm sharing the PPT?
We are live.
Okay. Good morning, everybody. Pat yourselves on the back for making it to day 2 of DevSpace. And this is just the beginning, as we have a lot more in store for you guys. I'm Rahul Distari, and I'll be one of your hosts for the event, along with Bhavi, Gauri, Gursahej, and Navami, some of whom you might have met already. Let's get started with the event we have in store for you guys now. You might have come across these following terms before: cloud, scaling, Kubernetes, Azure. Well, do not worry if you have never came across these before. We've got you covered. I'm very ecstatic to introduce you to one of our keynote speakers, Mr. Nills Franssens, a senior cloud solution architect from Microsoft. Mr. Nills Franssens is a technology enthusiast and a specialist in multiple open source technologies. He is the author of the second edition of the book, Hands-on Kubernetes on Azure. He has been working with public cloud technologies since 2013. And Mr. Nills' areas of expertise include cloud, Kubernetes, networking, and storage in Azure. And in his current position as senior cloud solution architect at Microsoft, he works with Microsoft's strategic customers on their cloud adoption. When he's not working, you can find Mr. Nills playing board games with his wife, Kelly, or running one of the mini trails in San Jose, California. Today, Mr. Nills will be sharing his knowledge on CI/CD, automation, and cloud, some of the most essential technologies of the current age. Please join us in welcoming Mr. Nills Franssens.
Thanks, Rahul. This has been one of the most exciting introductions I've had so far, so really big thanks to you. Let me get my screen sharing going and just give me a shout when you can see my screen.
Yep, we can see the screen.
Okay, thank you. And thank you for everybody for attending, and thank you to the organizers for having me as one of your keynote speakers. And before we start the actual technical content of this presentation, I wanted to take a quick minute to just take a pause and realize what we're doing right now. I'm originally from a small country in Europe called Belgium, living in California in the United States, delivering a keynote for an event organized in India. And isn't this a wonderful world where we live in, where we can share all of these experiences with each other worldwide? And this is a nice experience for me as a human being, but it also has an impact on our modern software development. And if we think about diversity and inclusion, diverse teams have the ability to build very inclusive software. And I think the event here today is just one of the examples of diversity being able to give you different perspectives and showing you the art of the possible. And just to give you an idea of how important diversity can be for people is, there's one story of an app that was developed here at Microsoft called Seeing AI. And the Seeing AI app may sound like an interesting app. It's an app on your phone that you can use to scan your surroundings, and the app will take, let's say, a picture and use artificial intelligence to give you information about what's going on in your surroundings. Now, for me as an able person with full sight, that might not sound as exciting, but for people with a visual impairment who are less able to see their surroundings, this has a tremendous impact on the way they live their daily lives. And The reason I mentioned this story is that the team that built that application had as a core team member a person with a visual impairment, and just having his perspective added a tremendous amount of value to the building of the app, and the app itself now adds a lot of value to other people. And before talking about technology, I just wanted to start off today with explaining to you that diversity and inclusion is something that's super important, and it can add value to your software, and it helps you to build software not only for one target group, but for the whole world. And as we're talking about software, I want to take you through a journey of modern software and how you can manage modern software using some new technologies like containers, Kubernetes, and then continuous integration and continuous delivery. My name's Nils. I am a cloud solution architect working for a company called Microsoft. If you want to stay abreast of some of the things that I'm doing, you can follow me on Twitter. I also maintain a blog where I share some of the technology explorations that I'm doing. So if you want to learn more about the work I do, any of those two areas is a good place to start. So let's start with the first topic of today, namely containers. And although the pictures show you shipping containers, we will actually be talking about what containers mean for modern software. And if we think about our application platform nowadays in 2021, a lot of applications are very distributed in nature. And a single application might be built up of multiple different microservices. And each different microservice might itself have multiple components to it, and different dependencies and different languages that are used. And if you think about the problem that this causes, is we have this amalgamation of technology stacks to support running applications. And all those different stacks need to be supported and need to be able to run on a whole different slew of infrastructure. And if we just take one of the examples here on the slide, if you look at the left here, we have a couple of background workers using Python 3, and we have an API endpoint leveraging Python 2. And it already shows you one of the challenges of making sure that all of your infrastructure components have both Python 3 and Python 2 available. And what this generates is a sort of matrix from hell, where if you develop software and you start off on, let's say, your own laptop, and you need to then bring that software to different servers and maybe to a production server in your own data center, and you might want to scale out to the public cloud, this generates a number of challenges. And there's a piece of technology called containers that can help with resolving this challenge. And if we think about what a container is, and I'll show you the use of containers throughout this session, containers are a way or are a technology to package a piece of software, meaning application code that you develop, together with all of its dependencies. Dependencies being both the runtime as well as any additional packages that are needed to run your application. And what you see here on the slide is a very simplified way of looking at what a container can be. And I will actually show you an example in a second of a small little Python web application that I wrote for the demo of today. And this Python application requires two things. The first thing that it requires is a Python runtime to be available. And the second thing is it uses a package installed through pip. And for those of you not familiar with Python, pip is a way in Python to install different packages that your application can then use. And what I'll do in building the container is I will create a container that packages the application itself with the Python runtime and any of the pip packages that are required. Now, before we jump into the demo, I do want to take just a quick second to stress the fact that although our demo is based in Python, containers work with all software languages essentially. So what you're seeing today with Python and pip packages You can easily replace this with Java and a jar file and any dependencies there, or with C# and NuGet packages and .NET. So don't get stuck upon on the Python example. That's just one of the examples that I want to walk you through today. So with that, I'm quickly going to flip the screen and show you the first demo of today. And to start off, we will switch to the command line. And what I will show you here is the small little application that I have developed for you. And the application itself is very simple. I've got this application.py file available here. And I can run this locally on my laptop directly without the involvement of any containers. I can just run this in Python. And if I were to run this right now, this starts a development web server that I can use. And if I connect to that web server in my browser, you'll be able to see that I can connect to my web app on port 8001. So let me just zoom in and make that a bit bigger. So here you see that we have this hello world being returned to us. This is very simple. This is the web app running as you would run any other Python application from the command line. Now, what I'll do next is I will take this Python command line application and I will turn this into a container using a command line tool called Docker. Docker is a very popular tool to both build and run containers, and we'll use that today. And what Docker uses to build a container is a file called a Docker file. And as we see the files that I have here in my local directory, you see that next to my application.py file, I also have this Docker file. And let me just show you what's in this Docker file. This is a very small example, but I actually start from another container image, and there's a whole bunch of base container images that are available for you to start working from. I'm working from a container image that's using Python 3 in the Alpine version, and Alpine itself is just a turned down operating system that's optimized to run in containers. And what I do next is within that container, I configure my working directory to be a certain directory. I then copy all of the files from my local folder, meaning I'll copy the Docker file, the application.py, and the requirements.txt file into the container. I will run a command called pip3. Pip is that package manager for Python. I'll install all of the requirements for the application to start running. I will expose port 8001 and then run the application. And what I can do now is I can build what we call a container image. And to build an image, you use the Docker build command, and you give that command something called a tag. And the tag is just a way for Docker to identify different images that you are creating and running. And let's just call this one Python live demo :v1, because this is the first version. And I will provide it with a dot, the dot just representing the local folder that I'm working in. And if I hit the enter key here, this will cause Docker to start building the application. And you will see that it is going through the build right now. What it's doing is it's executing the steps from the Docker file. It's loading some metadata. It's then starting from this Python 3 Alpine image that we defined earlier. It's setting the working directory, copying the files, and then running this pip install command. Now I have available on my local system a container image with the tag Python live demo, and I can actually go ahead and run this application and do a Docker run. I will provide it with some port configuration so that I can also access the application through my local browser. So I will link port 8001 to 8001. and then provide it with the image name that we provided, being Python live demo v1. And so if we hit the enter key and start running the application, we should in a couple of seconds see that the app is running. So the application is running again. We are getting the same output as before. And if we were to go back to the web browser and go to localhost on port 8001, we should be able to see this same hello world message that we saw earlier. So just as a quick recap, what we've done up to now is we've taken an application, a Python application, with some dependencies, the dependencies being a package in pip that needs to be installed. And we baked that into a container and then ran that container on my local machine here. Now, this is all good, and this is easy to work with software on my own local machine. But let's take this to the next step. Typically, when you're developing software, you also want to share that software with others, either with your colleagues for them to be able to run this as well, or even share this on servers so that you can actually serve traffic for end customers. So the way that is done with containers is after you have built a container image, often those container images are pushed to something called a registry. And the registry is just a centralized location where container images can be stored, and they can then be used by other systems that can then pull in those images to start running containers locally. Now, what often happens is after an image is built by a developer and pushed into a registry, you will then have servers connecting to that registry, pulling in the image, and start running that software in production and start serving actual end user traffic. And so let's go back to our demo, and let me show you how we can push a container image to a registry. So I'll go back to the command line here. And if you remember, we built this container image locally using the Python live demo v1 tag. Now, I will make a quick change to the tag of the Docker image and then push that into a registry that I pre-created for you. And the registry itself is something I can show you already. So if I go back to my browser, I pre-created a container registry in Azure that I can use to store my container images. And if I show you what I have here under repositories, under repositories, you will see that I just have a single repository for now called Bellhop Engine, which is another software project that I'm working on. But we will now take our Python web application and push that into this container registry. And so the first thing we have to do for this is we have to log in to this container registry, which I can do using an Azure command. So basically, I'm using Azure, telling it I want to use the Azure Container Registry and log in, and then I'll provide it with the registry name. This should take just a second. And once we are logged into the container registry, we can then take the container image we built before and prepare that to be pushed into the registry. And what we have to do that is we will do a command called docker tag to add an additional tag to our container image. And I will tag the image Python live demo, and I will actually just attach a prefix called nfacr, which is the name of my container registry, .azurecr.io, and I will still call this Python live demo v1. So this will tag the image, and I can then do a command called docker push, and docker push will then move the image from my local machine into the centralized registry. So I can do that with docker push nfacr.azurecr.io / Python live demo v1. So we will have this finish. This is now pushing the different layers of my Docker image into Azure. And after this has finished, I will show you that this image is now available from within the Azure Container Registry, and others, if they would want to, and they have the authentication to my registry, could then go ahead and start using this container image to start running my application. And so the image has now been pushed. And if I show you this container registry and I refresh, you see that we now have this Python live demo application available from within the container registry, which is nice. And let's go back to the PowerPoint slides and let's take this to the next step. Because what I just showed you is something that I don't recommend you to do for a production system. For a production system, I actually encourage you to automate this process. Because as you're building software and you're frequently building software, you will frequently need to make updates to your container images. And as you need to do something more often, it pays dividends to automate this process. And within software development, there's a process, or actually two processes, called continuous integration and continuous delivery that are used during software development to do what I'm actually encouraging you to do, to continuously build a container image, and afterwards, once the image is built, continuously push that into a production system. And so if we think about continuous integration and continuous delivery, both are very frequently used in, let's say, the same sentence and almost as a single process, and they're intertwined, but they are two separate steps in, let's say, the software development lifecycle. Continuous integration, which is the first step, is the process of continuously building and continuously testing your software. What that means is, as you are developing software, and once you have developed a certain feature and you're ready for that feature to be shared with your colleagues, you would commit that code to a source code repository, typically a Git-based system. And based on you adding that code to source code, that would trigger off a continuous integration job, which would then build the application, run some tests on the application, and finally create an output. And the output is what is often called an artifact. And that artifact is typically something that can be deployed in the next phase, which is continuous delivery. If we think about that artifact for just another second, and we are now talking about containers and container images, and the artifact of the continuous integration phase will be the container image. But continuous integration and continuous delivery have been around since before containers were around, and are also used for non-container based software development teams. And if we think, for instance, about a Java application, you can also do continuous integration and continuous delivery with Java. And the artifact in that case would be a jar file. Or if we're thinking about a Windows application, if you're developing, let's say, a Windows desktop application, the output would be your .exe file, your .exe file. Now, that artifact, whatever it may be, let it be a container image, a jar file, can then be used by the continuous delivery phase to continuously release or deploy that software in different systems. Different companies with different maturity levels of software development take different approaches to continuous delivery. Companies like Netflix and Amazon have documented practices where they actually release software into production multiple times a day, and that has good benefits for them. Other companies, like, let's say, a bank, has stricter control requirements, and a bank won't be continuously releasing software on, let's say, a daily basis, but they will frequently release software to a testing environment where people can actually test the software and have that as an automated process as well. And if we bring this all together from, let's say, an end-to-end pipeline perspective, where you start as a developer is you always start just writing code, and that is called the inner loop of development. And if you add containers to the mix, you would start using container images coming from a registry. The slide here says Azure Container Registry. I do want you to realize that containers are not exclusive to anything Microsoft or Azure is doing. There's other registries as well. Other cloud platforms like Google Cloud and AWS also work with containers. So this is not exclusive to what Microsoft does. But as a developer, you develop your code locally. You pull in certain base images that you want to work with from a registry. And once you have written and developed a piece of code that you want to share, you would then push that piece of code into a source control system. And as I mentioned before, typically you would see a Git-based system being used, GitHub, Bitbucket, GitLab. There's multiple different versions available. And once your code is available in source control, then you would trigger the continuous integration phase, where, as I mentioned earlier, you would build your code into an artifact, you would test that code, and as the output there, as you might have seen in the previous animation, your container image is pushed into the registry. Then the next step is continuous delivery, where you take that container image and you deploy that into a production environment. And we'll talk about production environments for containers in a second a little bit more, but let's start with taking the demo that we just built, meaning the CI pipeline, or meaning our Docker-based Python web application, and take that to the next step and integrate that with a CI pipeline. And to show you this, I will switch over to my web browser and show you a demo using GitHub. For those of you not familiar with GitHub, GitHub is an online community of software developers where you can work on open source software, and some of the biggest open source tools are being developed on GitHub. Think about things like Kubernetes, Visual Studio Code. A lot of the container tools themselves are developed in the open. GitHub also has some private versions available in like an enterprise edition that companies can use. But I'm right now just using the free and open version of GitHub. And what I have prepared for you is something called a GitHub action. And GitHub actions are a platform to do continuous integration and continuous delivery. There's multiple different platforms available. This is not exclusive to GitHub, but it's just a platform that I gravitate towards and that I use most frequently. And to show you what I built is, let's start off with just going into the second demo of today, which is container_CI. And what I have here is exactly the same thing that you saw earlier on my machine. I have the same Docker file, the same application, and the same requirements.txt. But what I have additionally here, and since this is a demo of CI, is I created something in GitHub called a workflow, which will trigger actions to be run. And I have this CI workflow available for you. And what this CI workflow does, and let me zoom in maybe just a little bit, is this will trigger, the first thing we define here is when this is supposed to run. And I define that for every time there's a code push into my main branch in either the container CI folder or on this pipeline file specifically, I want this action to be run. And what this action consists of is the following. I have a single job right now called CI, continuous integration, running on an Ubuntu system, and I'm running a couple of steps. The first step is a very simple one. It's a git checkout. And what this does is GitHub actions are run on servers hosted by GitHub. And the git checkout action makes my source code available on that server. What I then do is I do some login operations. I log into the Azure command line with a secret that is actually stored within GitHub and that is securely stored within GitHub. So anybody looking at this file doesn't see the secret. I'm the only one that can see the secret, and that's good for security purposes. Then I'm logging into the Azure Container Registry. This is the exact same command you saw me executing earlier on my own laptop as well. And then the final step here is I'm building and pushing the container image. I'm doing that from within the context of the second folder. I'm telling it to push the container image, and I'm giving it this tag. I'm calling it Python web app/demo. That's a different tag than we used earlier, but just to show you that this looks very similar to what we did earlier. So let's go ahead and trigger this action to run. So to trigger this action to run, I will go ahead and I will make a small application change here. As you can see, the application itself is pretty simple. It's a simple Flask app returning hello world. And to make this a little bit more interactive, let me change the source code from within GitHub. And instead of saying hello world, let's make this say hello world from the live pipeline demo. I will commit these changes directly. And as I commit these changes, this will cause the pipeline or the GitHub action to be triggered. And if I go to that GitHub action, you'll see I've been doing a couple of tests before the keynote, and now this action is running. And one thing I want you to notice is this number 5. I didn't point this out in the code itself, but I'm using the number counter of the GitHub action to be included in my image tag, so that as I run this multiple times, I can have multiple different versions of my container image be available. And as this is running, we can actually go ahead into the CI step and see the different steps and the different logs that are being generated for us. And this is moving relatively fast, and what's being generated is less important. But as you can see, right now, I made a code change, and without having to run any commands myself, I made the code change. That code got checked into source control. This automatically built and pushed an image into the Azure Container Registry. And I can actually go back to that registry and show you that if I were to refresh this, you see that now I have a new image available, namely the Python web app/demo. And I can then take this image and go ahead and run this on my local machine. So can I copy the full one? No. So let me just take this and run this on my local machine. So going back to the command line, I can now do the same Docker run command that we used earlier. azure.cr.io, Python web app/demo that we just generated in using the GitHub action. The one thing I forgot was to add the /:5, because we just created the 5th version of this image. And as we let this run, this will see that Docker sees that it doesn't have the 5th version available locally. What it's now doing is it's connecting to the container registry, pulling in the changes that it doesn't have locally, and starting the application. And as the application is now running locally on my machine, I can go ahead and reconnect to the browser and go to localhost port 8001. And if the demo gods are kind with me, and they are not, because I made a mistake, sorry about that. I forgot to do one thing in my Docker run command. Sorry, folks. I forgot to add the port configuration. So I'm now adding just that it needs to connect port 8001 to my local machine. And if we add this, this should start the application again. The difference that you're seeing now is right now, Docker cached the container image locally on my machine. So it noticed I already have this image, so I don't need to download it again. And as I now connect to localhost on port 8001, we should see hello world from the live pipeline demo, which was the update we made to the application, which is what I wanted to show you. So going back to the next step. We've now run a container. First, we built it locally, and then we had that container be built by a CI/CD pipeline. Now I want to take you to the next step and think about running containers at scale. And running containers at scale requires a piece of software that is called an orchestrator. And as I'm thinking about the word orchestrator, I always like to think about let's say the director of an orchestra. The person is not called an orchestrator, but I like to think about it this way, because the person leading an orchestra has the wonderful job to conduct the music that is generated by hundreds of musicians sitting in front of him. And each and every individual musician in an orchestra is very capable of operating their own instrument, but it's the conductor or the director of that orchestra that makes sure that you have a symphony, and he makes sure that when the right instrument has to play, he will direct those instruments to start playing at the right rhythm, at the right tone. And it's the director, or let's just call him the orchestrator, that makes sure that all of the individual pieces line up together and create a symphony of music. And you can think about an orchestrator in terms of software orchestrator exactly the same way, because running standalone containers can create a number of issues. If we think about that, there's a number of things that can go wrong with software. First, the hardware can go down. Like you're running a container, or we're running a number of containers on a machine. What were to happen if the machine goes down? Or maybe worse, maybe not worse, but what were to happen if a certain machine gets overloaded and either the CPU or the memory is at 100%? What happens then? Or what happens if you have an application crash and a certain container just dies? How would you recover from all of those events? That's where a container orchestrator comes in. And a container orchestrator, like the orchestrator of the orchestra, has a number of jobs in making sure that the individual pieces of your application and the individual pieces of your software work together. And an orchestrator has, let's say, a couple of elements to it. The first one, and maybe the most important one, is the scheduling element. And scheduling refers to making sure that the right container runs on the right server in what is called a cluster. With scheduling also comes the responsibility of affinity and anti-affinity. If you're not familiar with that, affinity means scheduling two containers very close together. Anti-affinity means scheduling two containers always on separate pieces of infrastructure. An orchestrator will also do health monitoring, and in case if there is a health event, will trigger a failover to happen. In the previous example, if one of the containers were to crash, an orchestrator will take over and will actually fail that over and start up a new one. An orchestrator can also scale applications, either by doing that manually, where you can yourself add new containers to a certain set, or by doing some auto scaling and even integrating scaling operations with health monitoring to make sure that your application is always running healthy. Then within an orchestrator, there's two networking elements that are important as well. Just plain networking, as in connectivity between the different containers running in a cluster, and also the function of service discovery to make sure that if you have different services running in your cluster, that different services can even discover themselves and know which IP to connect to. And then finally, an important skill is to help you with doing application upgrades. And I will actually show you an application upgrade in the next demo. But coordinating application upgrades and making sure that your application doesn't go down during an upgrade is an important task as well. And I've talked a lot about the abstract pieces of orchestration up to now. There are multiple container orchestrators out there, but if you look at the market today, Kubernetes is the industry-leading container orchestrator. Kubernetes is a piece of software originally developed by Google, but donated to the open source community. And Kubernetes is not managed just by Google anymore. Google has a number of software engineers working on the project, but as well do many other companies. There's hundreds of companies working together on the future of Kubernetes, including Microsoft. And I'm proud to say, even myself, I've added code to Kubernetes to make it work better, which is very exciting. And there's a couple of key pieces to Kubernetes. The first piece is that it's portable. Both Kubernetes itself, as well as applications running on top of Kubernetes, are portable across public cloud, private cloud, and even multi-cloud. And to give you a small little example, I'm working with a customer right now that is running an application in their own data center on top of Kubernetes and needs to bring that application to the cloud to get additional scalability. And because they're running it on Kubernetes, the migration is actually pretty straightforward, and they can use many of the same definitions of their application to run that in Azure as compared to in their own data center. Kubernetes itself is also extensible by design. The API of Kubernetes allows you for multiple hooks and plugins to be added to it, so that Kubernetes can be used to run containers, but also to connect with other systems. And for instance, you can even get a SSL or a TLS certificate through a Kubernetes plugin, which makes it a really powerful system. And finally, Kubernetes is self-healing. Self-healing from an infrastructure perspective, like Kubernetes itself, but also from an application perspective, it'll add certain capabilities to your application to self-heal from certain failures. And let's have a look at what this practically means. And I'm not going in a lot of depth here because there's a lot of moving pieces to how Kubernetes works. But from a very high level perspective, if you want to create or deploy an application on top of a Kubernetes cluster, what you would do is you would create a piece of configuration, typically in a YAML file. And YAML itself is not important, but YAML is a markup language, and it's the language used by Kubernetes to define your configuration. And if you want to deploy an application, you create certain configuration and deploy that against the Kubernetes API. Once the Kubernetes API received your request, it'll look at your configuration and apply that configuration to the cluster, which will most frequently entail creating or scheduling a container on one of the nodes in the cluster. What then happens on your cluster is your cluster itself will get the task from the Kubernetes API to schedule and run a container, and it will connect to a container registry, pull a container image from the registry, and run that image locally on the cluster. And so why don't we have a look at what it means to deploy to a Kubernetes cluster first manually without the CI/CD pipeline, just to show you what goes on underneath the covers. So back to the command line here, and I will navigate to another folder for the manual Kubernetes deployment. And what I have here is I've got two files. I've got a deployment.yaml file and a service.yaml file. And let me show you what's in there. In the deployment.yaml file, I've got the definition of the actual containers that need to be created. What you'll see here is I'm creating a deployment, passing it some metadata like a name and some labels. I'm telling Kubernetes how many copies of this application I want to be running at any time. Some more metadata here. And then finally, I'm providing it with the container image. And as you might realize, this is the same Python web app image that we built earlier. Although here you see that in the previous work I was doing, I added tag number 2, but we recently created tag number 5. So I'll change 2 to 5. We'll exit out of here and write the changes to the file. And what I can now do, since I made updates to my deployment file, is I can do kubectl create -f deployment.yaml. kubectl is a command line tool that is often used to interact with the Kubernetes API. And if I were to finish this creation, this will go ahead and create the Kubernetes, start creating the containers on the Kubernetes cluster. While that is going on, I want to show you the other file that I have. And the other file I have is service.yaml. What I have in here is, instead of a deployment, I'm using a service. And a service in Kubernetes is a network level abstraction to be able to connect, because as you saw, I'm creating 3 containers. Using a service, I can use a single IP address, connect to any of those 3 containers, and I can add a load balancer to that, so that the load between those different containers is also load balanced. And I can do the same thing as I did earlier. kubectl create -f service.yaml, and this is creating the service, and this will provision a load balancer. So let me show you 2 things now. First, let me show you the containers that Kubernetes created for us by using the command kubectl get pod. The word pod in the context of Kubernetes is, let's say, it's an important concept to realize. A pod is either one or multiple containers that are always grouped together. And in our demo, our container is a pod. It's almost synonymous in this case. But as you see, I now have 3 copies of the Python deployment manual running. And if I were to do kubectl get service, we also have our Python service manual that got created with a public IP address. And if I take this public IP address and connect to the application, you will see that we're getting the same hello world from the live pipeline. Now, I did promise you that I wanted to show you how an application update looks from within Kubernetes. And so if we go back to our container registry, you remember that at the beginning of the demo, we just created our hello world as the Python live demo :v1. So what I'm going to do now, just to show you what an update in Kubernetes would look like, is I am going to go back to the command line, and I'm going to edit the deployment file. And instead of using Python web app /demo, let's change this to, what was it? Python live demo :v1. Let me just verify that one last time. Python live demo v1. Okay, so I'll write these changes to the file, and then I'll go ahead and do kubectl apply. And with using kubectl apply, I can actually apply updates to the deployed application. And I will do deployment.yaml. Before I hit enter here, I'm quickly going to execute a second command after I've issued this update, just to show you what Kubernetes does as it's updating that application. So once this is done, I will do kubectl get pods. And right now I am following what Kubernetes is doing with the -w, which means watch. And as you're seeing, Kubernetes, as I was updating my application and pointing it to a new container image, started creating new containers for me. Once those were running, it killed or it started terminating some of the other containers. It created a new one. Once that was running, it started also terminating other containers. And just to show you that this update was successful, if we go back to this live demo and we were to refresh what's on this web page, we now get the hello world example that was part of our first image that we created together. And so this is how you work with Kubernetes, and this is just a very high level initial example. But as we make our full pipeline complete and we finish the circle, let's focus now on step 4 and 5, where we already have a process in place to build container images. Let's now focus on how we can automatically deploy those container images onto our Kubernetes cluster. And that'll be the last demo of today, where we look at the end-to-end container-based CI/CD pipeline. And so let's go back to our GitHub repository and go into the code here. So in this 4th folder, I have my container-based CI/CD pipeline to Kubernetes. And I have 5 files here, same Docker file, same application, and same requirements.txt that we've been using all along. And here I've added the deployment file and the service file from the 3rd demo that we just saw. And as we go ahead with this, let's show the pipeline as well. So this pipeline looks very similar to the previous one that we saw in the 2nd demo, where, let me just get the zoom right. We are triggering this on changes to certain path. We are then running the CI job, and the CI job is almost exactly the same as the one you saw in the 2nd demo. The only difference being that I changed the name of the container image, and I moved that from just demo to CD, standing for continuous delivery demo. And then I added a new step. I added the CD step for continuous delivery, which depends on our CI step that we execute above. And then here we do a couple of different steps. First, we do a git checkout to get our code. We then get the credentials to our Azure Kubernetes cluster, which is pre-created for us. What I then do is just some command line changing, where I'm changing the predefined container image version, and I'm changing that with the version including the GitHub run number, which is the version that we create as we're adding new container images. And I then apply all of the updates in this folder, and that finishes the update. What I then finally do is we wait for the actual deployment to finish, and we can do that using another kube control command. And then finally, we're getting the public IP of the service that got created. And so with that, let's go back to the beginning and make a final application change. And let's change this hello world into something more exciting. Hello world. This is the final demo of this presentation. Commit these changes. And as with the 2nd demo, this will now again trigger a GitHub action to be run. Let's check this action out. This has multiple stages to it. So this GitHub action will first run through the CI stage. CI stage meaning getting the files and pushing the Docker image to our container registry. So let's have a look here. And this is going to take, let's say, a couple of seconds to finish. So let's watch the logs until this is done. Okay, so this successfully finished. So this means that we now have a new image in our container registry. And if I were to show you this, we go back here. We now have a new image, namely the CD demo that we just created. And then what's happening here is we're going through the deployment. And if we look at this output, you see that Kubernetes slowly but surely updated the deployment from 0 to 1 to 2 to a full successful rollout. And then finally got the public IP of the service. And if I get this public IP and browse to it, if all of the demo gods are kind to me, we should be seeing, if we are lucky, no, let's give this one more try. Huh. This is a little bit of a bummer. Okay, I had to be just a little more patient, but as you see, this is the final code change we made, final demo of the presentation. And this is just making that whole circle complete, where we wrote some code locally, pushed it into a source control system, had the CI step build a container image, had our CD process push all of those changes into our Kubernetes cluster. And as you see here, all of this end-to-end gave us an update to our running application. And so that also concludes the presentation that I had prepared for you here today. If you want to learn more about Kubernetes, Rahul mentioned this in the introduction, but I was one of the co-authors on the second edition of the Hands-on Kubernetes on Azure book. If you want to learn more about running Kubernetes on Azure, this book is available as a free download. So you can go ahead and download this book right now. If you want to be patient, I am at the moment working on the third edition of this very same book, which Microsoft will make available for free as well. So if you give this another, let's say, 4 to 6 weeks, depending on how the publishing process goes, the third edition of this book will also be made available for free. So you have a completely updated guide on learning more about containers in Kubernetes. And with that, I want to express a heartfelt thank you to everybody who attended this session, and also to the organizers for having me. I hope I was able to guide you along the path of modern software with containers and Kubernetes. And with that, thanks everybody for attending.
Thank you, Mr. Nills. That was an amazing keynote, and based on what I'm seeing on the YouTube live stream, the audience definitely loved it, and they even had a few questions for you. So, do you mind answering them?
Sure. Go ahead.
Some general questions. So, Shinitsu has asked, how exactly can we use Kubernetes in project implementation? How would you say is the best way for beginners to get started with them?
That is a good question. So the way you would use Kubernetes in a project is to actually run the result of the software that you build. So that's where you would use it. If you want to get started, one of the best resources is my book, of course. But there's also, the way I got started with Kubernetes is there is an excellent course on edX. And if you want, I can share the link with Rahul as well. That takes you from zero to hero with open source Kubernetes as well. So either download the book or follow the edX course to get started with using Kubernetes.
Another question for you, Aditya has asked us. Thank you, Mr. Franssens, for this session. My team and I really needed this. What are the advantages of using Kubernetes for web deployment? Like, what are the differences that I could experience?
So the biggest benefits from using a system like Kubernetes is the ability to very easily and dynamically scale your application. I think that's one of the big benefits. And a second benefit you get as well is portability between different environments, meaning portability between either starting development on your own laptop, going to your own data center and multiple clouds. Kubernetes is sort of like becoming the default API layer that different clouds make available to you. So if you want to start off with using Azure and then move to Amazon, using Kubernetes will make that move a lot easier for you. So that's a very short answer to the question of what the benefits are.
Another question for you, Bright Thanks and Check Good have asked this. Could you please tell how a beginner can learn Docker and Kubernetes effectively, much like any good roadmap to start with?
Yeah, that's an excellent question. And I would actually start with learning the basics of containers and Dockers before you move into Kubernetes. Docker is, or containers in itself, are a very useful concept, even without using Kubernetes. And the way you would get started is, as I just shown you, start with a sample application, do a little bit of Googling on, or Binging if you want to use Bing. Start just by looking at some examples, follow some tutorials, and it's a little confusing to start off with. I'm going to be totally honest. Containers, it took me a while to wrap my head around it. But once you understand the concepts behind Docker and containers, that's a really good way to start your roadmap in learning. And once you got that figured out and you have your application available in a container, that's when you can start exploring. That's when you can start exploring things like Kubernetes to operate those at a larger scale.
And your final question for today, Aaron May has asked this. How often and how effective is it to use concepts of Docker in a hackathon?
I would say that it's within a hackathon, it might not be as useful during a hackathon as you're very quickly and very frequently doing development. However, what I would say is, as you're developing different pieces of an application during a hackathon and you're working with different people together who might not always have the same tools installed on their laptop, doing things using Docker and having a Docker file available for people to just build and test the application locally without having to install any of the prerequisites, that can actually help your development cycle as well. So it's a little bit of investment initially to write that Docker file and get that working right. But once you've done that investment, if somebody new joins your team and doesn't have the tools installed, they can just do Docker build and they're set up and they can start running and developing the application. So it's a little bit of an investment for a hackathon, but it might be worth it.
Thank you. Thank you for sharing your knowledge with us. Everyone who has tuned in for today's talk, please go check out our Instagram handles where you can find a short quiz based on what Mr. Nills has given us today on his keynote. Show us at CSIVITU what you have understood from this keynote. And once again, I'd like to thank Mr. Nills Franssens for considering us and giving us his time today. And I also want to thank every participant who has taken part in this keynote today. Thank you, everybody. Thank you, Mr. Nills.
Thank you. And